In this video, I'm going to demonstrate how you can perform an evil twin attack with an OpenWrt router. Most of the tutorials I found about this use the airgeddon script, and I don't really like that because I don't like to have a script do the heavy lifting for me. I like to understand how everything works. And in this instance, I can't use airgeddon on a router because it requires a window manager. And I would run a window manager on a router if I could, but it's not really possible with the router I'm using. So I ran airgeddon on my Raspberry Pi and launched an evil twin attack with captive portal using that script. And while it was running, you can navigate to the temp directory and you'll find all of the files airgeddon is using. And I copied those off and figured out how airgeddon is doing things under the hood. And I decided to stick with how airgeddon does things because I found it pretty clever and convenient the way they capture passwords from the captive portal page and actually check it in real time against the handshake of the target network to figure out if the entered password is correct or not. But the default captive portal page that comes with airgeddon is pretty underwhelming. I didn't like it at all. So I found this thing. This is a custom captive portal page from Stan, and I really like the look of it, and I figured out how to integrate this with how airgeddon does things. So I picked this up, made a bunch of modifications, and also removed as many unnecessary files as possible, because when it comes to putting this on a router, a lot of times you're going to be dealing with really low RAM and flash storage, so you want it to be as lightweight as possible. And here we have it. So this here is the index.html file. And this value right here adjusts the look of this web page on mobile devices. The original template that I found on GitHub would look like a desktop site, even on mobile devices. So this line right here scales the website for mobile devices while leaving the desktop version untouched. And if you make any changes, you're also going to have to repeat those changes for the other files to keep the look consistent. And this part of it captures the password, and I changed the action here to have it be sent to check.htm, similar to how airgeddon does it. And right here I have the check.htm file from airgeddon, and I made a bunch of modifications here. Now if you notice, the check.htm file is actually a bash script masquerading as an HTML page. And this is the part about airgeddon that I found really clever. So this part here is to simply make this page look really similar to the index.html and the updating.html page, which we will get to that later. So over here it picks up the password and it echoes it into the currentpass.txt file, which then gets fed into aircrack-ng alongside the handshake for the target network, which we capture beforehand and place in this directory on the OpenWrt router. And if aircrack-ng is successful, we know that we have the correct password, and it creates this success file which doesn't actually have the password in it. It is only to signal to us that the attack was successful and the password that is currently present in currentpass.txt is the correct one. While I was editing, it came to mind that this method of capturing the password has a major flaw. Whenever the attack is successful, it creates the success file and leaves the correct password in currentpass.txt, and we can take a look at it there. But if a user on the target network enters something else into the captive portal page after the successful capture of the password, it would replace whatever's inside the current pass.txt file, potentially with a password that is now incorrect. So I made a modification here to this line where it actually sends the contents of the current pass.txt file into the success.txt file as soon as aircrack-ng executes successfully. With this, we don't have to worry about any further entries into the captive portal page erasing the real password. It will always remain in the success.txt file unless, of course, it gets replaced by another successful capture, in which case it doesn't really matter. And once that's done, it sends this to the web page, and then it uses this function to redirect the user to the updating.html file. And this one is just a fake loading display that tells the user that it's uploading the firmware now and everything. And if aircrackng doesn't work, we know that the password is incorrect, and it gets echoed into attempts.txt, and it redirects the user to the main screen, which to do that, it uses the redirect to function. And the same thing happens if the password is less than 8 characters, or if something unexpected happens, it's just going to send the user back to index.html. And we can take a look at all of the functions in the style.js file. Redirect to is the one that sends the user to index.html, and redirect 1 is the one that lets them proceed and sends them to updating.html. And this is for the show password function on index.html. And now the way that this thing works as a bash script instead of an HTML file is we can actually set it up to be executed as a bash script in LiteTPD, which is what we're going to use to host the captive portal page. This is why check.htm has a different extension, because we can easily assign that extension to be run with bash. And there's a few other settings here which I will get to later. And an important thing to keep in mind is the downside of running the check.htm file as a bash script. We're going to be accepting certain special characters in the password field, which would allow someone on the captive portal page to potentially inject commands, allowing the user accessing the captive portal page to hack the hacker. So to avoid that, we need to block certain special characters, and we can do that by adding this right here in these two lines. What this is going to do is it's going to filter out these special characters from any password entered into that input field. Now, while this keeps the hacker safe, it comes with the obvious downside of those characters simply not being captured and skipped over, which if the target network's password does include any of those characters, it's going to result in aircrackng failing even when the user enters the correct password into the input field. But that would still be saved as an attempt in the text file. So this is really for you to decide. And to take a look at the folder structure of the web server, this is what it looks like here. And in the files directory is where we will place the handshake of the target network. And this is where the web server is going to save all of those text files whenever something gets entered into the captive portal page. I'll be uploading all of these files to Codeberg. You can find a link to that in the video's description. So I think that's about it for the web page side of things. I am now going to move over to the OpenWrt router, and I'm going to demonstrate how you can set up an access point with captive portal functionality. So for this demonstration, I'm going to be reflashing my router, clearing all of the data, and starting from scratch. At the time of recording, the latest stable release of OpenWrt is 24.10.0. Remove all the settings, and I'll wait for this to finish up. I'm doing this on the MI Router 4C. I picked it up for about $10 and flashed OpenWrt onto it immediately. You don't ever want to use one of these routers with the stock firmware from the manufacturer. At best, you're going to be dealing with a bunch of security vulnerabilities, and at worst, you're going to have a router that's constantly spying on everything you do. It only has 16 megabytes of flash and 64 megabytes of RAM, but that's more than enough for this attack. Okay, so the first thing I'm going to do is I'm going to switch over to the subnet that I'm most comfortable with, and this is not working. Well, that's just how it is sometimes. Come on, just do the thing you're supposed to. Okay, I somehow managed to get here. So now I'm going to switch over to the subnet that I like to use. We don't want to use the same subnet that we're going to be using for the captive portal, since that can cause conflicts. Alright. At this point, I'm going to connect my router to the internet to download the necessary packages. Okay, now that I'm connected to the internet, I'm going to connect to the router with SSH. I'm going to make it so that SSH is only accessible over LAN. Okay, I'm going to SSH into the router. And we need to run opackage update. I'm going to copy all of the requirements. This file is on Codeberg as well. All of these are pretty self-explanatory, except for Nano, which you don't need to install if you're comfortable with using V that comes pre-installed with BusyBox. And the SFTP server is also not necessary if you're not going to be transferring files to the router in the way that I do in this video. And we're going to do opackage install all of these requirements. So while that's installing, let's talk a bit about the LiteTPD configuration. The server is going to use all of these modules, and all of them are in the requirements list. This part here is part of what allows operating systems to detect the captive portal. You don't have to use the subnet, you can change it around if you like, and same goes for the port. This just specifies our index.html file. This just tells the server how it's supposed to treat all of these extensions. Same for this one. And this is the access log side of things. Whenever someone accesses the captive portal page, you're going to be able to see certain details about the user in the litetpd.log file. So that's really all there is to this file. It's really straightforward. Once all the requirements are installed, I'm going to take care of the configuration side of things. And make sure you follow all of these configuration steps precisely. Even a slight mistake somewhere can render the entire thing unusable. There's 4 configuration files that we're going to need to edit. The first one is DHCP. You know what? This part is what we need to add to the end of the config DNS mask section. But I feel like this does make it work on Android, but I feel like we might have to specify the IP addresses of the Microsoft and Apple servers as well to make it work on Windows and Apple's operating systems, I think. I'm not sure about that, but I'm just going to do it anyway. That's better. I think that'll help it work better. So I'm just going to copy this now and put it in here, just like that. And now at the bottom of this file, we're going to copy this part, just like that. And now we can save this. And let's move on to firewall. So in this file, we need to go all the way down to the bottom and paste everything in the firewall file. There we go. Now we'll do the network file. Scroll to the bottom, paste, and we're done. It's a lot quicker to do it this way compared to doing it through Lucy, so alright, last file. And make sure you look through these configuration files to ensure there are no incompatibilities with your existing configuration. Like you see here, the Wi-Fi interface name this access point is using is Wi-Fi Net 0. So if you have a previous configuration that's already using the Wi-Fi Net 0 identifier, you're going to want to change things around or it might cause some issues. So the DHCP file is just going to set up these addresses for DNS resolution. The firewall creates the necessary firewall zone and it's set up to only allow DHCP and DNS, so just the bare minimum, and this sets up the port forwards necessary for captive portal functionality. The network file sets up the bridge interface for the access point, and the wireless file is of course the access point itself. So this is going to create an access point that's called captive with a random MAC address for now. We're just going to be testing if everything works, and once everything does work, we can change the access point to precisely mimic the access point of our target network. Once all of that is configured, we need to head on over to etc LiteTPD and remove everything in this directory. And we need to change the port that Lucy is using to avoid any conflicts. So I'm going to head over into the UHTTPD file. And here we need to change port 80 to 88. You don't have to do this. You can change the port of the captive portal page and just modify the firewall rules to accommodate for that. But I like to keep it on port 80. So this is what I'm going to do. Now I'm going to cd into the folder that had all of those files. From here, we need to send over the litetpd.conf file into the appropriate directory on the router. Now I'm going to get rid of all of these files except for the handshake to save up some space. Okay, now it's clean. Going to get back. Once all of the configuration files are in place, we need to reboot the router for everything to take effect. And we need to send the entire folder into the temp directory on the router now. So I'm going to use the R flag. That's going to make it recursive. And there we go. Every time we restart the router, the temp directory is going to get cleared. You can place the web page on non-volatile storage, but if you do that, remember to update the directories in the check.htm file and the litetpd configuration file. And I'm going to SSH into it. Let me see if it works now. Alright, it does connect. Now notice how the captive portal page does not show up just yet. And that is normal. A lot of times you're going to want to wait until everything is set up and working, at which point you can go back and restart the litetpd service. It is automatically set up to launch at boot, but a lot of times you're going to have to restart it, especially if you make any changes to the interface. And now if I connect back to the access point, as you can see, it works perfectly. Let's try entering something in here. Well, before I enter something, let's take a look at the access log. So I'm going to cd into that directory. And here, you know what, this access log, I'm going to modify the configuration file so that the litetpd.log file gets placed inside the files folder alongside all of the other stuff. But for right now, let's just cat it and see what's inside. Oh wow. Okay, I'm not sure I'm comfortable displaying this on video, but it's just a user agent string. You can use this to figure out the phone model, operating system, and all that. Okay, enough of that. I'm now going to enter something in there. And of course it says that it's incorrect and sends us back to the main page. Let's take a look in here. And as you can see, we have attempts.txt. And if I cat it, the password was captured successfully. Okay, so now that we know that the captive portal page is working perfectly, we're now going to precisely mimic the target network's access point with our evil twin access point. So for that, I'm going to head over into Lucy and scan for targets. And there it is. That's the target network. This is a router that I own. And I'd like to take a moment to mention that you should only use this for legitimate penetration testing purposes and to test the security of your own networks. So this here is my own router, and I already have a handshake for it that I've placed in that directory. If you don't know how to capture a WPA handshake, there's a bunch of tutorials out there that you can take a look at. And before we perform the attack, we also need to do some reconnaissance on the target. Things like simply looking up their BSSID. If the target access point has not randomized their MAC address, you're going to be able to figure out the manufacturer behind that BSSID. And we can incorporate that information into the captive portal page. For the purposes of this video, I'm just going to stick with the default Cosmo theme that the captive portal page has, but you want to change that out to something else that is relevant to the target. if you can figure out the manufacturer of their router, and the MAC address can sometimes also let you know the ISP the target network is utilizing, since you might be able to recognize that router as a router that is usually given out to customers by an ISP. This is why it's very important to randomize the MAC address of your home network, because that information can be used by adversaries to make their attack more convincing. So I'm going to copy the BSSID of the router, and we need to open the check.htm file. And all the way down here on this line that has the aircrackng command, that's where you need to enter the BSSID. And of course, you're going to want to capture the handshake and place it in this directory with that exact name. I'm going to save this. And now we can get on to modifying our evil twin access point to precisely mimic the target network. So like we saw earlier, the name of the target network is CIA Honeypot, and it is currently on channel 1, and I already have the BSSID on my clipboard. Enter the precise name. We'll have to leave this open because we don't know the password to the network. And now in the MAC address, I'm going to paste in the MAC address of the target network. You're going to want to select the correct country. My router only supports 2.4 GHz. So if you have a 5 GHz radio, this will probably look a bit different. You can set up a dual band access point where both the 2.4 GHz and 5 GHz channel have the same exact SSID, if that is what your target network is doing. In my case, that is indeed what the target network is doing, but it is enough to only mimic the 2.4 GHz network. Alright, now for the channel. This is pretty important. If you're mimicking the exact same MAC address as the legitimate access point, you're gonna want to keep the channel different. If you mimic both the channel and the MAC address of the access point, it kind of makes it finicky. When I take a look at it on my phone, the evil twin access point does not even show up most of the time. And the deauthentication attack I'm going to be demonstrating in this video uses MAC addresses and channels to identify access points. So if the evil twin access point has the same exact channel and MAC address as the legitimate access point, it too is going to fall victim to the deauthentication attack. So in my case, because I'm mimicking the MAC address of the legitimate access point and the channel of the legitimate access point is 1, I'm going to set my channel as 6. You can keep the MAC address of the evil twin access point slightly different and mimic the same channel as the legitimate access point. That should make it so that the evil twin access point doesn't get hit by the deauthentication attack, but I don't know which one works better. I'm yet to try both of them, so that part is up to you. So with all that done, we can save it. And now I'm going to enable this access point. So now for deauthenticating clients from the legitimate access point. In my case, I'm going to need a Wi-Fi card that supports both 2.4 and 5 GHz. This is because the target network I'm going to be attacking is hosting the same SSID on both 2.4 and 5 GHz channels. So if I only deauthenticate the client from the 2.4 GHz network, their device may seamlessly switch over to the 5 GHz network and never even notice anything. So right here I have the wireless adapter I'm going to be using. It's wireless LAN 1 in my case. And it's a good idea to run airmon-ng check kill to kill any services that may interfere with the card when it's in monitor mode. Alright, now let's put it into monitor mode. There it is. Now we're going to launch aerodump-ng with the BSSID and channel of the target network, followed by the name of the interface. Alright, there it is. Now we need to do the same for the 5 GHz network. Let me make this a bit bigger. Alright, now to find the BSSID and channel of the 5 GHz network, we need to run aerodump-ng with the B option set to A. This will make it so that aerodump-ng only displays 5 GHz networks. And you can follow this with the name of your interface to find the BSSID and channel of the target network. Alright, I have it now. And there it is. Now we need to pick a client that we want to deauthenticate from both access points. You can run the deauthentication attack on the entire access point, but I find that to not be as effective as deauthenticating a specific client. So I'm going to copy the MAC address of this client right here. And then in the third window, we need to run airplay ng with the 0 option for deauth, followed by another 0, which basically makes it send deauthentication frames indefinitely until you stop it. Then we need the A option to specify the BSS ID. This one is the 2.4 GHz, followed by the C option to specify the client, and the interface name. I'm going to type the same command in the fourth window for the 5 GHz network. There it is. Now, before we start deauthenticating the client, we need to make sure that we're ready to look for the success.txt file in this directory on the OpenWrt router. Right now, all I have is the handshake for the network as expected. Now, when you run airplay ng, it'll often give you an error complaining about the Wi-Fi card being on the wrong channel. This is expected because we have aerodump-ng running on 2 different channels simultaneously. So you're gonna have to constantly run the command until it eventually decides to work. Now we will watch the entire attack sequence from the perspective of this client on the target network. Long day today. Oh, you Jeffrey shitting on Apple. Let's take a look. Oh, what's going on? It won't connect. I have another one with the same name. Oh. We're sorry for the inconvenience, an important security update. Yeah, looks like I'm gonna have to get this done before I can use the internet. Now, what was the password? Okay. Alright, I don't really remember my password. I'm gonna have to get it from my password manager. Okay, here it is. There we go. Oh, cool. Is the internet back now? So that was the entire thing. Like you saw, we need to keep checking this directory for the success.txt file, and as soon as we see it, we can stop the attack and get rid of the evil twin access point. Now we can take a look at the attempts in attempts.txt and the correct password in success.txt. I can't show this is actually my real password. The biggest flaw with this attack is that it requires the user to manually connect to the evil twin access point, and at least in my case, the phone kept trying to go back to the legitimate access point, which often interrupts the captive portal page. But I think that wouldn't happen if the deauthentication attack was a bit more strong. Perhaps it would work better if I had multiple Wi-Fi cards simultaneously performing the deauthentication attack on the legitimate access point. And range plays a key role in the evil twin attack. Ideally, you'd want the signal strength of the evil twin access point to be the same, if not better, compared to the legitimate access point. And that's what I really like about this setup. You can easily just strap a battery onto the router, shove it inside a satchel, and take it wherever you want. And to SSH into the router from your phone on the go, you could set up a secondary SSID to connect to the router and control it. Or you could potentially connect your phone to the router with any USB ports you may have available and set it up in a way that allows you to SSH into the router over the USB connection. I'm not sure if that's possible though, I haven't tried it myself. Or you could shove a Raspberry Pi alongside the router into your satchel and connect the Raspberry Pi to the router with an Ethernet cable and easily control the router wirelessly via the Raspberry Pi. So yeah, lots of possibilities there. I'm going to end the video here. Hope you found it informative and entertaining, and I'll see you in the next one.